Alright, in this video we'll be looking at problems off of page 312. This first problem I will be doing is like 6.41 and 6.42. Let's say the question asks me to determine the area underneath the z-curve to the left of some value. Area under z-curve to the left of (1.5). All right. First of all, this z-curve is also called our standard normal curve. And that will be a normal distribution. We use capital N to signify that, with a mean of 0 and a standard deviation of 1. So we'll begin by drawing that curve, a horizontal axis, and then our normal curve. It's a bell-shaped. You've probably heard that before, the bell curve. This is what they're referring to. It's single-peaked, and it gets asymptotically close. That is, closer and closer to the horizontal axis, but never touching. All right. This number indicates our mean. This is the mean represented. We use the Greek character mu for that. And this is the standard deviation, sigma. Mean is mu, and standard deviation is sigma. All right. So we will begin by centering it. Our mean is this number, 0. Standard deviation is 1, so we'll go up 1 and then down 1. Up another. And then down another standard deviation. And then we'll go up one last one. These lengths here are supposed to be the same. My picture leaves a little bit to be desired. -3 here. All right. So I want the area to the left of 1.5. I'll begin by marking that value on my normal curve. So here is the value I'm interested in. This is a z. That is negative 1.5, pardon me, 1.5, positive 1.5. And we want the area to the left, so I'm going to shade this area. This is what we're seeking. Okay, what is this area? Well, hopefully you know from the notes or your studies that from the mean below, that's 50%. This is another 34%, that's 84%. This is going to be something like 90% that's less than 1.5. How can we find it? Well, one way is we can consult a standard normal table. So if you just pull up a browser and search standard normal table and then hit search, you'll find many of them. I'm going to take this one that's about 4 down. It says PDF from stat at UFL. I'm going to select it because it shows a picture of the curve here. And you can see where they've shaded. The tables give you the areas to the left of some z value, and we want 1.5. Here's the negative z values. I'm going to scroll down until we get the positives. So here's 1.5, and since I want 1.50, it's this number right here, 0.9332. So this area, the area here is approximately 0.9332. Area is approximately, and equal with a dot over it or a wavy equals is approximately 0.9332. That is this area. All right, that's how you can answer questions 6.41 and 6.42. If it gives you an area between two, you should find both and then a subtraction. For instance, on 6.42e. Let me do 6.42d. (6.42d) asks us to find between. It says the probability, and that's the same as the area, from 1.14 z of 3.35. So in this case, you want to find between these two numbers. First, there's no difference between a less than and less than or equal to. The equal to portion of the inequality won't have any meaning in this context of this continuous distribution. In this case, you're going to find the area less than 1.14, you're going to find the area less than 3.35, and you'll subtract, and that'll find the area in between. Okay. Now I'm looking at one like 6.43. Like 6.43. In 6.43, they don't give us a standard normal curve. They tell us that we have some normal distribution, and they give us a mean and standard deviation. Let's say that we're talking about the height of adult men. Well, adult men, their heights are normally distributed with a mean of 69 and a standard deviation of about 3. Okay, it's a little bit less than that. That's pretty close. And I want to know what is the probability of finding a man that is that has a height that is above, greater than, again, greater than, equal to be the same thing here, greater than 72 inches. All right, I'll begin by drawing this normal curve. So I'll draw my normal curve. Have my mean in the middle, 69. And I'm going to go up and down 3. Up 3 would be 72. Down 3 would be 66. Down 3 more would be 63. And I'm going to go up 3 more would be 75. And it theoretically this extends infinitely, but we know with the height of people that does not extend infinitely. But our model, we consider it extending infinitely in both directions. All right, we want to know the probability that x is greater than 72. Well, that would be right on this line. This is an x value of 72. We want this area here. Well, we can already get an approximation. Hopefully you remember from before that the empirical rule said we were 68%, 95%, and 99.7% in our first, second, and third standard deviation. So what that means is we would have 34% in each one of these. Since we have 68% in one standard deviation, we'd have 34% in each of these. 0.34 here and 0.34 here. Well, we know we have 50% below the mean, and another 34, that would be 50 and 34, 84%. If 84% is to the left, it's going to be about 16% to the right. But how can we use this normal standard normal curve to find that? Well, the first thing we must do is calculate the z-score. The z-score is equal to some observation x minus our mean divided by our standard deviation. Well, this one's going to be very easy to find. We know that this is our mean, 0. So 1 standard deviation above and 1 below, 2 below, 2 above. 2 above, positive 2, positive 1. I don't have to show these positives, just made a little typo there. Well, we can see that 72 is at 1 standard deviation. We know this is going to be a z-score of 1, but if it wasn't right on there, how could we find it? We would use this calculation. Z equals x is our observation, in this case 72. Subtract from our mean, again, mean, this number, standard deviation, this number. Our mean is 69. Our standard deviation is 3. Well, 72 minus 69, that's 3. And 3 divided by 3, that is 1. So we want a z-score of 1. All right. We go back to the table again. and I want to find a z-score of 1. Here is 1. We're dealing with 1.0, and as you can see, that's 0.8413. That is, to the left of 1 is 0.843, or 84%. So for the right of, we would do 1 minus that. Thus, the AZ of 1 corresponds with an area that is approximately 0.84. 84% is to the left. Thus, the probability that Z would be greater than 1 would equal 1 minus this 0.84, and that is 0.16, or approximately 0.16, we should say, and that is 16%. Okay, so the chance of getting, the chance of finding a man that is 72 inches, that is 6 foot tall or taller, is approximately 16% if men are normally distributed in this fashion. So with this, you should be able to work problem 6.43 and beyond on this assignment. Recapping how we did this, all right? Problems like 6.43. Number 1, draw the curve. Okay, that is the particular curve with the distribution. Okay. Number 2, label and shade. You can get a good idea of how much the area is just simply by doing that. Number 3, find the z-score. Okay, and that's using this little simple formula. And number 4, go to that table. The table is going to find the area to the left of. Area left. And with that area is analogous to a probability. All right.